Solving an equation of the fourth degree. From a general equation to simplified equation. In general, a fourth degree equation is defined in the form a multiplied by x to power 4 plus bx cubed plus cx squared plus dx plus e equals to 0, where a is not equals to 0. Substituting y equals to x minus b divided by 4a, we obtain the reduced equation. Y powered by 4 plus p y squared plus qy plus r equals to 0 with coefficients p, q, r, which can be calculated using the next formulas. Solving a simplified equation. We add and subtract the summand 2s y squared plus s squared, where s is some unknown variable. We got y powered by 4 plus 2s y squared plus s squared plus py squared minus our summand 2s y squared plus s squared plus qy plus r, which is equals to the first three summands is a full square of y squared plus s plus p minus 2s multiplied by y squared plus qy plus r minus s squared. For now we assume that s not equal to half of p. Then we get y squared plus s squared plus p minus 2s y squared plus qy plus r minus s squared equals to y squared plus s squared minus p minus 2s multiplied by y squared plus qy divided by 2p minus 2s plus r minus s squared. To make the expression in brackets a complete square, we need to add and subtract q squared divided by 4p minus 2s squared. And we should also subtract the same summand. So we get y squared plus s squared plus p minus 2s multiplied by full square of y squared plus qy divided by 2p minus 2s and plus free term r minus s squared minus q squared divided by 4 and p minus 2s equals to 0. Now we want to find s such that 3 term is equal to 0. R minus s squared minus q squared divided by 4 p minus 2s equals to 0. Or r minus s squared multiplied by p minus 2s minus q divided by 4 equals to 0. Thus we obtain the cubic equation for s. 2s cubed minus ps squared minus 2rs plus rp minus q squared divided by 4 equals to 0. In this case, the simplified equation reduces to the form y squared plus s squared plus p minus 2s multiplied by y plus q divided by 2 p minus 2s squared equals to 0. Hence, we obtain the two quadratic equations y squared plus s plus minus square root from p minus 2s multiplied by y plus q divided by 2p minus 2s equals to 0. Since we consider that s not equal to half of p, the root of p minus 2s has two values. That is, we get four solutions of two quadratic equations. Let's go back to the cubic equation. 2s cubed minus p squared minus 2rs plus rp minus q squared divided by 4 equals to 0. If it has at least one root s not equal to half of p, we can use it. Now consider the case when all roots of the equation 6 are equals to p divided by 2. That is, it has the form 2 multiplied by s minus p divided by 2 cube, which is equals 2s cubed minus 3ps squared plus etc. equals to 0. Then all coefficients of this polynomial must be equal to the coefficients of the polynomial 6. In particular, the coefficient at s squared must be the same. In one polynomial it is equals to minus p, in the other minus 3p. That is, p equals to 0. Therefore, the polynomial has the form 2 multiplied by s minus p divided by 2 cube equals to 2s cube. And to match the coefficients at all powers of s, the values of q and r must equal to 0. That is, in this case, the above equation has the form y powered by 4 equals to 0 and has 4 coincident zero roots. The general algorithm. We reduce the general equation to the simplified equation. Y powered by 4 plus py squared plus qy plus r equals to 0, where p, q, r can be calculated using next formulas. If p, q, r all equal to 0, there will be 4 coincident zero roots. Y equals to 0. If at least one of the values of p, q, r is not equal to 0, then solve the cubic equation 2s cubed minus p squared minus 2rs plus rp minus q squared divided by 4 equal to 0. We choose a root s not equal to p divided by 4. Such a root is always present. Substitute s into the quadratic equations and find the 4 roots. Y squared plus s plus minus square root from p minus 2s multiplied by y plus q divided by 2 p minus 2s equals to 0. From roots of the simplified equation, we find the roots of the original equation using formula x equals to y minus b divided by 4a. On my website you can find a page on which you can solve equations of the power 2, 3, 4 online. We go to other and find the solving equations of degree 2, 3, 4. Here you can enter the coefficients of every equation and you can use the complex or real numbers. And the program automatically shows you polynomial and then find all of the roots. And you also can input the value of the roots, and the program shows the same, the polynomial and the roots. You can use quadratic, cubic, or quadric equations.